rotated so that you have lines going up at 30 degrees. And so if you look at your horizontal plane here, this is a 30-degree angle, and this is actually 30 degrees, and look at this, 30 degrees like that. So you have an edge of the object facing. So if I look at the orthographic views of this object, this will be my front. Let's call him the front. We look at the right side. So that's our right side. And of course we look at our top. And that's our top. So the object, we have an edge facing us, this corner here, this line joins this surface and this surface. So that edge is basically where these two edges coincide together, produce that. So this folds out, so you get your right side there, and then this folds up, and you get your top there. So we wind up with top, front, right side. That's why these have to stay in alignment with each other. Just like you open up a cardboard box. When you open it up, they hinge together. They stay in that formation. They're not offset or anything like that. Not front, right side. That's very basic, even in orthographic drawing. If you don't get that, you're going to be having trouble as a drafter. That arrangement, you only have one option to that arrangement, just to let you know. Instead of hinging my right side to my front, if I hinge the right side to the top, it folds up right there. Then we have top, right side sitting right here, and then front sitting right there. This is your alternate arrangement. That's it. When you're dealing with orthographic views, if you're dealing with mechanical drawings, this is your standard arrangement, and of course you got the other views that go with it. But if we're just dealing with these, this is your standard arrangement. This is your alternate arrangement. That's it. Okay, so now when we're dealing with an oblique drawing, if this is our horizontal plane here, the object is not rotated. You take the view, whichever view you use, you take the view as it is, and it's placed like so. So you're looking at it perpendicular to your surface. And then to show depth, you go back at an angle, and your standard angles are 30, 45, or 60 degrees. Those are your standard angles to match your equipment. 30, 45, your 36-degree triangle and your 45-degree triangle. And then you show, and then the object is constructed. So here the object is rotated, and to show depth, you're going back at 30 degrees. To show this, you're going back at 30 degrees. Here the object remains unrotated, and you show depth either going back to the right or to the left. So that's an oblique. Now, you got three types, and it's based on the depth here. So when we're dealing with an oblique, we have our we have our cavalier. With a cavalier, this distance is the full distance on the depth. With a cabinet, you're going back half distance on the depth. Everything is half. And then with a general, you're going back between half and full. That determines whether this is a cavalier, a cabinet, or a general. Let me come show you something. Yes, if I have a circle like that, and that's just the ortho view, and I wanted to draw this as a pictorial. If I take this and draw it as an isometric, then when you're looking at your isometric, you have your different planes that you can draw in. So I can draw on this plane here, I can draw on this plane here, or I can draw on that plane there. So if I decide that I want to draw on this plane, then I could come here and create a rectangle, if you're doing it on the board, that's equal to the diameter of this circle. So if we draw lines running tangent, then we'll get a square. So if we take that square and rotate it so that this is going at 30 degrees here, then we draw a square equal to these values here, then we'll wind up with that. And then if we take that distance here to produce that thickness, then we will wind up with that. So we got a square here, like that. Now if I was doing this on a board, then I can locate the center of that right there and construct an ellipse that runs tangent to the quadrants of that, like so. So that will be this outside. And then this thing actually has the back surface there. So I would construct an ellipse for the back surface as well. But part of that will wind up being hidden. So, and then we draw our tangent lines. So that looks like that. Then we had a hole in the center, so we can use the same center to construct this hole here. And if we construct that on the back surface here, and if they overlap, let's say they overlap a little bit on the back surface of that, where they overlap, that means I can see that. So when I get rid of all of this other stuff that I used to construct this, or if it was using light construction lines, I could leave the construction lines on the drawing. Then what I have here is a isometric of that plate right there. Yes.
A good rule of thumb is that the tangent lines on the sides of the circle should be perpendicular, parallel to each other.
Yes. Yeah. Yeah, these are going to be parallel to each other. Okay, so now that would be an isometric. And he's a little bit distorted, but anyway, you see the principle. If I were to do this as an oblique, I would start off with this as a true circle and with this as a true circle. As you see, not rotated or anything. Then I establish my tangent lines going back. Back here I will pick up the back portion of that, which is a true circle. And then I'll get a true circle for this here, so where that crosses, I'll see part of that as a true circle. And that will be an oblique. So this is a true circle, this is a true circle, this is part of a true circle to represent the back surface, and that's part of a true circle as well. So this would be your ISO, and these are all ellipses right here. And this would be an oblique, and then these are circles. So as far as what I'm presenting here, I'm presenting something that's, you know, easy to visualize and stuff, whether I look at it this way or look at it this way. But this is easier to draw because I'm dealing with circles. I have to deal with ellipses. So that's one of the things about obliques. When you have something and you can set it up where you get all circles that you're dealing with in the orthographic view of the oblique, then it's easier to draw. Especially in CAD. Because in CAD, I would have to draw this separately. In CAD, I could copy this to another portion of my drawing, and then copy this back at an angle, connect the lines, trim it out, and I got my oblique. So where here I have to set it up, I can't use any of the pre-existing dimensions on my object or any of my pre-existing views, because this, I can't take this and convert it to an isometric plane. I just have to redraw this as an ISO. Here I could copy this here and then copy this at an angle, just like I just copied that, copy this back at an angle equal to that thickness, and add that, trim out my lines that I should trim out, and I got him done. So, so that's one of the reasons for dealing with obliques. So you'll find, I got some drawings here, and on those drawings you'll find these guys, I don't know, in the old days you never saw ISOs or obliques, well, very seldom, because on an electrical drawing for a house where they're showing you the outlets and stuff, exploded like this, like this particular drawing right here. But I got some drawings in there where I just, you know, they show it, and they're using oblique, because it's, once they drew the front view of an outlet, then they can easily copy it. If they drew a box for that, they can easily copy it. And they show the plate here, and then the box here, and then the wiring coming through and showing you how to wire it. Which, you know, electricians shouldn't need all of that. They should know how to do that. But they show it on the drawing anyway. I guess since it's easy to do it now on CAD and stuff, might as well do it for them. In case they're dealing with an apprentice that doesn't do anything. He can't read the diagrams or something. I don't know. Anyway, so they are done as obliques. That way they don't have to deal with any ellipses whatsoever. Because your outlet there, you know, your outlet looks like that. And if you draw that as an orthographic view right here, well, it's easy to copy that and then just give it a thickness right here, and then copy that and show your thickness of that material right there, and then you got that little outlet right there. To draw that as an ISO would be more complicated. But to draw it as an oblique would be easy because you already got the orthographic view. You just copy it back, connect your line, show these thicknesses, and there's your that portion of your outlet there. And then however he looks, you're showing that to or whatever. See, it's a little bit easier to do it as an oblique. All right, so on here, I don't have much on this right here. But anyway, we got our oblique here. Let me go ahead and do that. Drawing sheet. Well, we'll do it on here. we take this and we put it on a drawing sheet. This is referred to as multi-view projection or multi-view drawing. To get to here, you got to do orthographic projection. So orthographic projection is a term used to extract your views, top, front, right side, so forth. But then when you place them on a sheet, add dimensions and stuff, and maintain that arrangement, it's called multi-view drawing. So we're dealing with an orthographic views as part of a multi-view drawing. So you use the terminology multi-view here. Now that says usually the front. Well, it depends. And it's usually the front, but it could be other views as well. So let's say, for instance, we have an object, and it's the stair step. We'll just say that right there. We'll just say that. That's our front. And then this is our right side of the object. And then this is our top. Well, when we look at those three views, which view is more descriptive? The front. Yeah. Because this doesn't tell me much, this doesn't tell me much, but at least this gives me a shape of the object. Typically, when you're dealing with obliques, that's the view that you use to set up your oblique, is the view that's more descriptive. A lot of times it's your front view, because when you set up a drawing, unless the front view is top front right side is in a standard arrangement, such as if I'm looking at a car, then I know what the front of the car looks like. So that establishes the front, the right side, left side, top, bottom, so forth. The object itself. But if I'm looking at an object that doesn't necessarily, a front view is not defined, then I can call the most descriptive view my front. And from that, I can get my top, right side, and so forth. But some objects are already defined. And you don't take a car and call the right side the left side, or the right side the front and stuff. You base it on what the car. Okay. It defines what views are there. So, in this case here, we set this up where we call this the front, because it's the most descriptive. So if I do that, then and to draw an oblique, I just draw the front as it is, but I got to show thickness. I got to show this depth here of the object. And just like an ISO, lines that are parallel in your orthographic view will remain parallel in the oblique. So to show my depth here, whatever that distance is, and depending on what type of oblique I'm going to draw, then I draw my lines that show my depth. My lines remain parallel. This remains parallel. These remain parallel because they're parallel in the orthographic view. And then we got this here, and this remains parallel right there. That's my oblique of this drawing. Now, when I did this oblique, let's say we decided to go back 30 degrees. And our receding lines went back at 30 degrees, and we drew them to the right versus the left. Mm-hmm. So, sometimes you'll see a drawing, or in the book they'll say, textbooks, it'll say draw an oblique. So your oblique might be a cavalier, front, 30 degrees, right. So what they're saying is, you got to draw a cavalier, which means that it's going to be a full-size object. This is true distance here, that's full distance here, full distance there. Based on your orthographic view.
So on the cavalier, the lines representing the sides would be exactly the same measurement as the actual depth?
Correct,
Okay.
correct.
So we basically just squash the image.
Squash it.
Yes. Well, we normally, when something's at an angle, the line would be shortened.
Right.
So we're just squashing the image, making it exactly the length,
Of the orthographic view.
the depth.
Yeah. So this will be a cavalier. We started with the front view. We do our 30-degree lines, and we drew them to the right. That's what we're saying. Yes.
When we draw a cabinet, do you just take half a measure?
Right. You're
Okay.
doing half the depth. Whatever the depth measurement is, you're halving it. So if I were to do this as a cavalier, let's say, not gonna work. Let's say yeah, everything's the same except we're going back half this distance. So that would give us a cabinet. So this would be a cabinet oblique. So whatever our depth is, we're halving that depth. This will be the full distance here. And of course, this will be full there. But we half the depth.
So now we're just basically scaling it.
We're scaling
Um,
on the depth.
Right.
Only. Yes.
also, when we do these drawings, I know they can be cavalier cabinet or general, but where do we put that on our drawing?
Oh, you can
where
put
do we
that.
put the words?
Oh, you can put that in your title block down there. At the title, you can just say, title cabinet, and the angle at which you're drawing this at. So the angle could be 30, 45, or 60. Right here. I generally have you guys do it 30 to 45-degree angles. So in the title, it could be a cabinet / 30 degrees. So you can just call it your cabinet drawing, 30 degrees. Or cavalier, 45, whatever we're going to decide on. And so if I make this distance here between half, because half is a cabinet, that full distance is a cavalier. So if I make it between half and full, then that's a general. That gives you a little flexibility. Because sometimes when you go back the full distance, it looks distorted. And that's a problem with obliques. You get some distortion. If I go to minimize that distortion, I could do a cabinet and it'll look more correct. Or I have the flexibility of changing that between that and maybe go 75%, and then that would give me an oblique. But whenever you do the distance here on your depth, if everything is cut in half or everything is cut by 75% or whatever value you use. Now, the point here is also, so I used the front view. Now, if I use the front view, this is the logical direction to go, to the right. Because if I use the front view and draw this to the left, where my receding lines, the lines that show depth, go to the left, then and depending on what happens there, I lose portions of this drawing. So this is more descriptive than that. And you always draw a pictorial to show as many features as possible. This is easier because you're hiding everything. especially if it's got a lot of features there.
Yeah.
And you hide it, and I get students that do that in AutoCAD all the time. I said, that's not the purpose. The purpose of the pictorial is to show the object, as many features as you can, so you set it up where you can show all of those features. Not to make it easier on yourself to hide stuff. You know, that's not the purpose. So that's part of the solution. I give you a drawing and you draw me, you know, and sometimes in the CAD classes, they're supposed to, at this point, determine the correct angle at which they're going to view the object. Sometimes it doesn't matter. I can look at it from the left or from the right. Sometimes it does matter based on what I'm drawing.